Okay, Mr. Minnick here, helping students trace, evaluate if statements in the programming language Java, similar to how they might do it on an AP exam. Reading this multiple choice question here, number one, we have a fairly typical grading scale at a average high school across the country, and we want to use code to choose what message prints out to the student. Either your grade is A, your grade is B, your grade is C, or your grade is E. Here at Why I'm Missing, we used to consider an F, the letter E. Anyway, for reasons of unknown to me, maybe because I wanted to keep the worksheet short, I took away the D. So this is the grading scale. It is what it is. You don't question the problem itself. You just evaluate the code and choose an answer A, B, C, D, or E. So the question, as you can read with me, says, for which values, meaning integer values, numbers, whole numbers, as noted here by that clue, int, for what numbers does this code segment display the correct letter grade? This is a code segment. It's not a working method like a main method, public static void main string args. It's not a class in Java. It's just a chunk of code. Okay, well, when they do this on an exam where they put in angle brackets with a different font, italics or something, an integer value in the range of, you're supposed to just assume that the numbers are guaranteed to be between 0 and 100. And when they say inclusive, they mean it could be 0, it could be 100. So let's make up some test cases. Test cases that I would use with this for this problem, I would use the boundary point 0. I would also test it with the number 100. Then I would test it with some numbers in between. Well, I would definitely test it with a number greater than 90, say 95. I would also test it to see if it reaches this area here, a number greater than 80 but less than 90, like a number in that bucket between 80 and 90. I'm not going to do 85 because the 5 in 95 was an odd number. I'm going to use 84 just to give some little variety to the numbers that I'm testing. And greater than 70, I'm going to go with a number that's really close to a B, but not a B, so I'm going to pick 79. So I just picked some interesting test cases. Oh, I should also pick a number that fits into that area, perhaps 69 itself, or 68, but I'm going to check 69 also to see if that properly gives the person an E. Pretty unfair because often that would be a D, but in this world it's an E, which is really an F. Okay, with these test cases, I'm now going to put my thinking cap on, and under time pressure on the AP exam, I got to do this quickly. I'm going to run these through the code. So, maybe you make a little column like I do on worksheets in this class, at least that I'm teaching, where I put the number that's stored in the variable there. Okay, the way an if, else, else works is you always start with the if control expression, and you plug the value in for whatever variable is being used in that control expression, and you ask, is it true or false? Is this set of parentheses simplified to a true or false? Well, 0 is not greater than or equal to 90, so that's a false. So because of the way an else if works, it trickles down then. The computer just ignores that possible then clause. And we check the control expression here, kind of like a cascading waterfall. We plug the 0 in there to see if it's greater than or equal to 80. That's obviously false. I know you can do this quicker on your own, but right now I'm going slow for the people that are just learning this on YouTube. And we trickle now down to this else if clause. That's false. And because of the way if, else if, else works, the else always executes. There is no control expression here that could possibly be false. That doesn't exist. It's not there. So I don't know how to erase that. Sorry about that. There we go. So we execute whatever's in the else clause, whether we like it or not. That prints out for the letter E. So the inputted value 0 produces the displayed output, officially that whole message, your grade is E, but I'm just going to put E because that's all I have room for there. So does that work correctly for a 0? Yes, it does. So when you trace the rest of these values, do you match the expected output for these values? Well, you can do those on your own time. I'm going to now try to short circuit this and skim over the possible answers to see if I can see some poor logic up above that would make this not work correctly. Does this only work for the numbers that are less than 70? Does it only work for the 0 and the 69 there? Does it not work correctly for these middle numbers that I have in my test plan? If that were the case, then you would circle the answer B. Well, we need to test another number that is greater than 70 to see if it would work correctly, in which case we could rule out B. Well, yes, for a 79, this would be false, this would be false, this would be true, and it would correctly print the C for a 79. So I can rule out B as an answer. Similarly, I can rule out this as an answer because I know that when I plug 95 in, it does print the A right away. And I know that if I plug this 84 in, it rules that out. And I know just because I already plugged the 0 in and correctly got the E, I know logically that E is not an answer because there is at least one value that does work correctly. So that rules out E. So I'm left with the answer A, which is the correct answer to this exercise, even without exhaustively executing all of these. I only executed a couple there in my head. Moving on to exercise 2. It looks the same, and often you'll see on standardized tests or in real life there are patterns. So a lot of customers often order the same shopping cart that another customer orders. So let's look at the answers A through E. Oh my gosh, they're very similar, except for this E. No, that's even similar. I just used the font, different fonts there when I typed this up. Sorry about that. Well, so what's the difference? Oh, the code segment's different. I see. This code is different from this code up here. So key in on, you did all that great thinking up here, key in on what the difference is. Oh, here they do less than 70 at the top in the if, but here essentially the less than 70 was the catch-all else. So does that change it? It certainly does. It does change it. Because if you real quickly check this one, you'll see that the number 84, when run through from your test cases, you can use those same test cases. This would be false. This would be true because 84 is greater than or equal to 70, and it would cause the letter C to be printed out. In fact, for 95, it would also print out a C because we would have a false and then a true. And because of the way an else if works, once one of these control expressions at the top are true, the rest of it's ignored, and there's no hope of printing out the correct message your grade is A, even though you earned a 95. That is so unfair. It must be buggy grading software. This would not be correct. I call this upside down logic. This putting the 90 at the top and the 80 and the 70 was correct. To save this, perhaps they could have said if average is greater than or equal to 70 and symbol, average is less than 80, end of parenthesis to match this parenthesis, then it would have been airtight logic and the C would have printed out only when the person has a number in the 70s. But they didn't add this extra and. But you say, well, the extra and wasn't up here in the similar area. Well, because it was top down, it worked correctly and we didn't need the and. So maybe you just go through life coding it with this extra and just to be safe in case a coworker rearranges the else if clauses in a different order. Maybe you just put that in your original batch of code. There are people that do that for style. So the correct answer here is upon further testing, I'm not actually going to give you the correct answer. I think you sensed the answer, or I might have said it earlier. So good luck figuring out the answer there. If no values work correctly, or we already realized that there are some that don't work, so we can rule that one out. Okay, number 3, this is difficult. We have 2 pieces of code that you got to compare. And right away, when you compare these to see, even before you skim over the answers, you'll see that this is structure-wise one if, else statement. This is considered one statement, even though these semicolons indicate that in each body there are statements nested. The whole thing is called a structure, but we also just call, the if part from here down, we call it a statement. Here, though, in segment 2, we have separate if statements. So these are actually 4 different if statements, all independent of each other, and that causes the code to work, that causes our sample data to our test cases to work differently. I'll just spot check one of them. Let's try that 84 again. If I put 84 here into segment 1, 84 is false up here in the if. It's true here, so it does print correctly that your grade is B, and it skips these 2 system out prints. But for an 84 here plugged in, this again is false at the top. Oh, and this is true. So they actually work the same. Oh, for which values of, well, they have the same. Well, so I know that the answer, well, I don't know the answer yet, but I know they work for the same for 84. So maybe you check another number, and maybe you strategically check a number that you can already see the difference. Oh, wait, I was so wrong. If this was true, well, that didn't hinge on the first if. This is not an else. So actually, I fell for the trick. And that is so easy to do. Look closely. If we run an 84 through here, where the value 84 is stored in the variable average, that 84 is false in this if statement, so this does not print, that's good. The 84 is greater than or equal to 80, that's true, so it does print this. But because these are separate ifs, we must execute them separately. They're not else ifs. So the 84 here is tested to see if it's greater than or equal to 70, and it is, that's true. So logically incorrectly, the grade book prints out that the person has, very confusing. It says that the person has a B, your grade is B, but it also says your grade is C. And, oh, it does not say this because that would be false. How confusing when a parent sees that the student's report card has a letter B and a C. Anyway, up here, only the B printed. So definitely A is not the answer. You can do the rest of this and see which of those answers remain. Have a great day.